When you finally understand what a Sidecar container is. If you missed our segment on Kubernetes and why Kubernetes is a must and Service Mesh, check them out first. The Sidecar pattern was really introduced by Google with its launch of Kubernetes. Just like a sidecar for motorcycle, this is a pattern to allow you to deploy a container alongside your mission containers to achieve decoupling and inject specific capability. The sidecar shares the same Kubernetes pod and can see and communicate with the main container in the same pod to enable multiple new concepts. This allows to decouple the logic in the sidecar container from the mission container. This is often used when the same logic must be enforced across multiple containers or all of them, for example. A good example can be for cybersecurity or for enforcement reasons. As you can see here, each pod has a proxy, a reverse proxy called Envoy, and Istio uses a sidecar pattern to inject the proxy alongside each of your services. That means that now your reverse proxy injected by Kubernetes automatically act as a reverse proxy to control your traffic across your entire stack. Now Envoy, the reverse proxy, is able to inject a mutual TLS tunnel so that all your traffic is encrypted. The beauty here is that if you have to update Envoy, the reverse proxy, you can do that without having to update all of your services, because Kubernetes can inject the new sidecar container without impacting or coordinating with each team that's now consuming it. In this example, the sidecar acts as an authentication or policy enforcement point to allow or deny traffic, enforcing zero trust across your entire cluster. So the beauty is you can inject this sidecar across all your containers, and now you know that you have a zero trust enforcement point across your entire stack. So let's take a look at how a sidecar container is injected. First, let's say you have two Kubernetes pods. Maybe you have one here with a mission container about your search engine for your e-commerce application. So that's search right here. And here you have another one with your product detail page. Now you have a product service. Here, if you had to have these two pods and these two services communicate, either you would have to use libraries for each programming language. And let's say this is in Go, and this is in maybe Java. Well, now you have two different services with two different programming languages, and they have to authenticate, they have to use crypto, and you would have to share dependencies across all of these containers and teams. Now you're tightly coupled because you have to inject this library here that will be shared to do authentication, service discovery, encryption, etc. That's not how we would do this, right? With a sidecar container, you don't need this. And instead, you would have here the Envoy proxy from the service mesh. That's injected automatically inside of every pod by Kubernetes. So that's pretty convenient because you can now update Envoy without having to coordinate or go talk to each of these teams. It's automatically injected. And the traffic now would instead be hijacked by the reverse proxy. So the traffic will go this way. Let's say it's coming from the Ingress API, right? So here would be the API ingress. And now Envoy will then decide, can I talk to this service or not? If I have another service here, let's say the billing service, Envoy here is also injected automatically. But now you could say, hey, you're not supposed to talk directly between the two here, and Envoy will prevent that traffic here. The search is not supposed to talk to billing. But here, search and product that would be whitelisted, enabling the traffic to flow with a mutual TLS tunnel, and each of the service will have a short-lived identity and certificate. So that gives you a lot of flexibility to inject here, a lot of capability. The Envoy proxy does API service discovery, takes care of the issuance of certificates that are short-lived. But it's also able to manage the traffic and whitelist the traffic, act as a load balancer, canary release, A/B testing, centralizing telemetry, looking at observability. So you have all the tracing of all your requests. All this is seamless and provided by a Sidecar container that's now decoupled from your mission software. You can imagine the possibilities are limitless. Thanks to a Sidecar container, you can define a large-scale reusable behavior and different capabilities and inject them automatically or not across your teams. No need to share dependencies or library. This is injected via Kubernetes, and the Sidecar container gets the same visibility than your mission containers with the same access to network, etc. But it's not sitting inside of a container like an agent would in cyber on a virtual machine. It's injected as a Sidecar, so if a malicious actor gets a foothold in your mission container, the Sidecar is still capable of seeing exactly what is going on. If you compare that with an agent in a VM, the agent is immediately rendered useless because the malicious actor is controlling that virtual machine. Another example could be for logging. Let's say you want to have the same uniform logging capability across all your teams, but you don't want to share libraries and dependencies across various programming languages and teams and create tight coupling, worse, having to coordinate releases. That's exactly why you moved away from monolithic to microservices, right? Now, a Sidecar logging container could effectively have visibility to your network traffic or the logs created by your mission containers and feed it to a centralized log repository or data lake. For example, something like Loki or Fluentd can be injected as a Sidecar pattern to push your logs to Elasticsearch. When you are enabling teams to use the best tool for their job, that often means they may use different types of databases and programming languages based on what is best for their mission. So yes, you don't want to have to maintain a bunch of libraries for logging and cybersecurity capabilities for each languages and having to coordinate and share them across teams. That will be a massive bottleneck and ensure your team fails at being decoupled. There comes the Sidecar pattern. Simply use a Sidecar injection to push those capabilities across your entire cluster. So now you're guaranteed that your teams are using the same capabilities and you will have the full visibility on what's going on. Amazing. In fact, the Sidecar pattern can even be used by teams to reuse functionalities between containers or ensure that the same mission behavior is implemented. So this isn't just for cyber or operation teams. This can be used by development teams as well to build a Sidecar pattern that are mission driven, that can be built into Sidecar container and shared across mission teams as well. And last but not least, the Sidecar container application can be written in a completely different language from the mission container, so you can also use the best language to get the job done. There you have it. A Sidecar pattern is a massive enabler to decouple work between teams. In this case, it can enable cyber capabilities to be decoupled from your mission teams or your service mesh team to be decoupled from your mission teams as well. Instead of having to share libraries or dependencies and coordinate releases between teams, the Sidecar is injected at scale and there is no risk for teams to be using the wrong library version or get behind. That's a game-changing enabler for your DevSecOps implementation.